Well, hello, children. Welcome to drawing a Bohr model. All right. So Bohr used Einstein's observations to come up with a theory about where electrons orbit about around their nucleus. Bohr suggested that electrons only orbit at defined distances from the nucleus. Bohr suggested that when an electron moves from one orbit to another, it absorbs or emits light. Electrons are located in defined shells, which are located certain distances from the nucleus. Electrons cannot exist between these defined shells. Electrons can gain energy to move to higher shell, or they can lose energy to move down to a lower shell. Electrons are more stable when they are closer to the nucleus. It was also found that electrons fill the shells in a certain order from outside to inside. Also, the number of shells that an element contains is predicted by the row it is found on the periodic table. So, if we look at our periodic table, and hopefully you have yours out. If not, give it a pause and get it. If we look at row 1, hydrogen and helium, remember rows are horizontal, side to side. 1 shell. If we go down to row 2, lithium through neon, they have 2 shells. And as we go further down, 3 shells, 4 shells. So when you labeled your periodic table, we numbered 1 through 7 for the rows. And that tells us how many shells we can find in those particular elements in those rows. See? Patterns. Rows tell you how many energy how many energy shells that each element has. So again, row by row, 1, 2, 3, 4, 5, 6, 7. Now remember there are subshells, but we don't get into that this year. We're just focusing on the principal or the main shells. The periodic table can also tell you how many valence electron an element has. So this should be some review from yesterday. Remember that valence electrons are the electrons in the outermost energy shell in an element. So valence electrons are electrons. They're not a different type of electron. They're just electrons. They're just the electrons that are hanging out on the outermost shell of that element. Valence electrons are important because they determine if and exactly how an atom of an element will combine with other atoms to form molecules or compounds. And we will be studying that next week. So super important that you get all this foundational stuff down. All the elements in the same family, that's our columns, will have the same number of valence electrons. Columns tell you how many valence electrons an element has. You'll notice again, it's 1 through 8. Noble gases. These are full. Column 1, all have 1 valence electron. So forth. The boron group all have 3 valence electrons. Nitrogen group, 5 valence electrons. Now, we're going to draw. So if you were in on office hours, you heard me say you're going to be doing this in PowerPoint because to have you print it out and draw it, not everyone can print. Again, you can draw these out for yourself for practice, but everything you submit will be via the PowerPoint that is assigned to you for this particular assignment. Something you might want to put, or you should put on your periodic table, you want to put how many electrons fit on each of our principal shells. So for the first shell, 2 electrons. So that first shell is going to be the innermost shell closest to the nucleus, and they only hold 2. The maximum they can hold is 2. So every element, with the exception of hydrogen, is going to have 2 electrons on that first shell. When you get to the second shell, you're going to have 8 electrons. So it can hold up to 8. It can't hold 9. Can it hold 7? Yes. And be like, well, how come it doesn't have 8? We'll get to that. Well, again, if an element has 7 electrons, you can't give it more. Then it would be a different element. So anyway, make sure you write down shells 1 through 4, and that 1 can only hold 2, and that these other 3 hold 8 electrons. You notice it says for a Bohr model, we include all electrons. So Bohr model, we draw all the electrons. When we get to Lewis dot tomorrow, you'll notice we're just diagramming the valence electrons. Lewis dot is a lot easier than Bohr, but Bohr is super important to understand how an atom works, how the element then combines with other elements in our periodic table. All right, so let's try it and we'll see how wonky this is. So you'll have something similar to this. You won't have a periodic table in front here on your slides, but on mine I have it. Not that I can see it, it's kind of small, but whatever. All right, so you start with, here's lithium, find it on your periodic table. Lithium's in the second row of the first column. The symbol for lithium is capital L, lowercase I. It's column or group. So column, it's in column 1 or group 1. The row, the period, row, period, the shell's energy level is 2 because it's 1, 2. It's the second row down. Number of protons. How do we find number of protons? Do you remember? That's right. Its atomic number tells us that. So lithium is atomic number 3, which means lithium has 3 protons. Total number of electrons. Well, that's going to be the same as the number of protons. Tree. And then valence electrons. How many valence electrons does lithium have? Well, it's in column 1, so that means it has 1 valence electron. You seeing a little pattern here? I hope so. So our element symbol, I'm going to start with this guy, and I'm going to move this up. And within this, Li. Then I'm going to take, so I'm going to need, click, click, click. I need 2 shells. So I'm going to take the first shell, and I need the second shell. Meow, meow, meow. Wee. So I have 2 shells. Fabulous. 2 energy levels, 2 shells. Now, and I don't need this one. This one's here as a pattern for what we're doing. How many electrons? So we have 3 electrons. We're going to start with our first, again, the innermost shell. We start placing our electrons on our first shell. And our first shell can hold 2 electrons. You're going to have to probably copy and paste like I just did. Control C and then Control V to paste. Okay, so I now have my first shell is full, but we have 3 electrons. I just thought of a different way to do this. Okay, so energy shell 1 is filled. So then our valence electron, or our last electron, goes on energy level or shell number 2. So how many electrons do you see? 1, 2, 3. I have 2 shells. I have 3 electrons, and I have 1 valence electron because I have 1 electron on the outermost shell. Let's try another one. Aluminum, or as one of my students would say, aluminium. So the symbol for aluminium is capital A, lowercase l. The column we find aluminium is right here. So this is column 3. What row do you find aluminium in? 1, 2, 3. Number of protons. Aluminium is atomic number 13, or 13 as my dad would say. So that means it has 13 protons and 13 electrons. How many valence electrons does aluminium have? Well, here's column 1, column 2, column 3, column 3. So that means aluminium has 3 valence electrons. Fabulous. Now let's make it. So first we'll start with the symbol Al, and let's bring that up to a working area. Beep, 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 beep. Now, energy shells. How many am I going to need? Yes, I'm going to need 3. So I'm going to need all 3 of these if I can click on them. That would be fabulous. There she is. Oh, look, the whole thing just went. Technology. And it's doing it again. Oh, my life. Oh, for some reason. What's happening? There we go. Beep, 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 beep. And then we need a second one. 2. You know, when I draw these on the board, they're perfect circles. Psych. All right, and we need one more. Uno más. Yay, look at that. 3 shells. All right. So if 1, 2, 3 shells. Now we're going to need some electrons. So I'm just going to paste a few in here. Well, actually, we're going to need 13 of them. So guess what? I'm going to paste, was it 4, 5? Oh, I hate when it does that. 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So start with, again, the innermost shell, shell 1. Shell 1 can only hold 2. So we're going to put 2 little electrons on shell number 1. So shell number 1 is full. Now I need to fill up shell number 2. Shell number 2 can hold 8. So I'm going to start putting, just like watching paint dry. I'm really trying to go as fast as I can without being a total mishmash. Three, now let's go all the way here. 3. We're we're halfway there, children, halfway there. Okay, that's 6. 7. All right, now we have 8. Yes, fabulous. So we have 8, but we have 2 left over, which means I did not make enough electrons. I should have 3 left over. Look, we have 3 left over, which makes sense because we should have 3 valence electrons, right? 3 valence electrons. I have 3 left over. My first 2 shells are full, which means these 3 go on the outermost shell. I'm hoping some of you just went, oh, I so hope that's happening right now. I can't see you get that when the light bulb goes off. I miss seeing that in your little faces when you get it. There you go. So that is a Bohr model diagram of aluminium. I'm going to try one more just because. Neon. Oh, neon's a noble gas. Neon's going to be all the way over here in column 8. So, neon, symbol, capital E, lowercase e. Can I say capital E? Capital N, lowercase e. Column, or group number, is 8. It's actually group 18. Our row, it's in the second row. Number of protons, so neon's atomic number is 10, therefore its number of protons are 10, and that means the number of electrons are also 10. Number of valence electrons, so it's in column 8, which tells us that it has 8 valence electrons. Fabulous. So let's do this again, children. Let's put our symbol and E, and we'll let me drag. Yeah, that's chaos. Arrows are your friends. I'm gonna go ahead and make 9 more electrons. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Energy levels. Come on, clicky click. There it is. So we're going to need 2 shells. 1 and 2. Oh, that is fabulous. I heard that. Okay, we have our 2 shells. We have our 10 electrons. Let's move our electrons now. So again, we start at the first shell. And the first shell holds how many? Can only hold how many, children? That's right, 2. First shell gets our first 2 electrons. Look at that. So 2 minus 10 in my book, 2 minus 10, I should have 8 left over. Great. How many does the second shell hold? 8. Yes. So that means we're going to have a full second shell. We have 8 valence electrons. We had 8 left over. We have a full second shell, which means this is a very balanced element. It is noble. It does not mix with the other peasants in the periodic table. Fabulous. I almost feel like these are bees going to the hive. Pardon me. Dos más. 1 and 2. There we go, children. There's our Bohr model of neon. Super, super easy. Please make sure you practice your making these. This isn't something you can do in 3 seconds, obviously. Take your time, practice. You have a test or you have a quiz on Friday, so I wouldn't wait over the weekend to practice this because your quiz is Friday, not Sunday. So you have to take it on Friday. If you have questions, please come during office hours on Thursday to ask any questions on how to do, if you're confused at all with Bohr. Or what comes tomorrow is Lewis dot, which is a lot easier. But this isn't too bad. Super, super easy. Go ahead and practice, and I'll see you later.